Hello, everyone. Thank you for making it to our trio talk on the room configurators and modular configuration. I'm going to introduce our presenters for today. Andre is our CG supervisor. Ash is our VP of product management, and Chen will be joining us shortly. He's having some Zoom issues. He is our implementation manager. With that, I will hand it off to our team who will give us a wonderful presentation on modular configuration.
Perfect. Thank you, Amanda. Cool. So let's go over the agenda. What we want to do is go, first thing is just explain what does modular and spatial configuration mean with specific examples. Talk about some of the challenges the implementations team have to this day. Then switch over to the Threekit platform and do a walkthrough of how we address some of those challenges, and then end with what is left, what else do we have planned? And we'll swap screens, we'll share some demos of live projects and the platform. So first thing on modular and spatial configuration, let's see, is Chen here yet? No, okay, I'll try to explain it. If he joins, he can run the demos. If not, we'll go through it. So basically we categorize them into three different types of experiences. What's common across them is there is a spatial and component-based aspect to it. So by that, I mean, you may be manipulating the product in physical space, you may be moving it around. And also, it's not one central product. The product is actually a collection or a grouping of sub-products or items. And as we go through the demos, that'll become clear. But that's generally the pattern across these three experiences. And then we broke them down further into three categories. There is a typical kind called freeform. So think of sectional configuration or a sofa where you have pieces of the sofa and you move them around freely in space. There may be some physical constraints and attachment points. And why don't we go and look at a demo of one of these? This is the Lovesac project. So what's common with these configurators is as a end user or customer, you actually end up manipulating both objects in the player here and also in a typical more configurator form on the side. So on this end, you'll see I can move pieces of the sofa in space. There's some highlighting and you'll see there it's snapping. And on the right-hand side, I can also interact with the configurator and add new pieces. Once I add those, then I get to interact with them again in physical space. Hi, Chen. Are you good to go? All right, I'll keep going. As soon as you're up and running, just interrupt me and you can take over the screen. So the recap, freeform configuration, it's pretty straightforward. You have different pieces of a product and you can move them around freely in space. Now they're constrained, and you can see here they're constrained to the floor or the horizontal plane. I can move them around. There's some highlighting, there's some interaction between the pieces, but it's fairly freeform. The only rules are attachment points and the business side rules that, for example, here, if I do a side, the sides obviously can only attach specific ways. Moving on, the grid type. So grid is a layer on top of freeform where there's more physical rules. So there's specific placement for the different components. So if I open up a browser.
Sorry, Ash, I'm all set on my side.
Perfect. Go ahead and take over. I'll stop sharing.
Okay.
And feel free to recap freeform in case I missed anything about freeform.
Let me choose the. Sorry, it seems I'm not. Sorry, I have issue of sharing my screen. So could you just demo it? Sorry.
Yeah. Why don't I share and you can narrate and just let me know what you'd like me to click.
Yeah. So could you just add a random block?
Mm-hmm.
So the one big difference between a grid and freeform is the grid only allow your adding atom to the specific location, and they are typically restrained or bound by the physical of your atom. Like in these blocks, there are certain holes that are separated in certain distance. So this is where it only allow you to position your instrument. And in this example, you can also, if we can add another instrument here. So it add the swap feature. So if you overlay the two instrument, it will swap it for you. And also, as Harsha just demoed, you can move the instrument in front of the box. You can see there are three dot there. So this just make a feature make user easier to manage the instrument in a box when the box are full of, like there won't be an issue if it's pretty much empty, but if they're almost full, then it will just make it easier. Yeah, so this is a typical example of the grid configurator. And we have another example, the Boston tag. So this one is more of an example of 2D grid. Yeah, so if you can add and change the width, yeah, 60 is fine. You have to select the feed to be able to process. Yeah, this one. And then uprights in upright section.
Right. I'm sure it's right in front of me and I'm missing it.
On the right.
Size fee. Mm-hmm. Oh, I'm sorry, uprights. Yeah, over here.
Uprights and two double bay.
Mm-hmm.
And then go to the shelving upright accessory on the top. Yeah, so you can add shelves here. And it's the same, like if you zoom in, you can see the uprights, they have the kind of a great spot there that where it only allow your shelf to be attached in this certain space. So overall, this is an example of 2D grid. But in terms of the, yeah, besides the grid structure, there are other like constraint like collision. So it will stop user moving or jump to the next available position if you're trying to overlay to a shelf altogether. Yeah. So the third one, California Colors, we put it here. We put here because it has a different UI interaction when working with the spatial configurator. Instead of dragging directly in the scene, you see it actually interacts with the UI. So you add items from UI, and then you drag in the UI as well. But when you release, it will update the 3D scene in this case. So this is internally, it's also a great spatial configurator, but it's just a different way of interaction. Okay, so finally, the third one is basically it's a configurator that might combine these two approach together. An example here is the PRX. So, yeah, so if we can add a rack. I guess it's just taking time to load. So it is, so if you drag it left and right, you can see that the rack are attached to this down, which obviously makes sense. And besides that, the rack also has another layer of constraint that it can only position on the floor. But if we add another accessory here, so it's bar and color. Sorry, it's bar and color.
Oh, right here.
Color. If we add a bar, so barbell one, just select any of them, and at below you can find there's a storage section and there's add a storage, which will store that on the wall. So in this case, the movement actually combined two, like you can move it freely vertically, or you can, yeah, it's a little bit hard to select, but in terms of vertical movement, like actually a free form, you can move it continuously. But again, along the wall, you can again also position that only on the stone. So this is kind of a configurator that combined two spatial type configurator type.
Excellent.
Yeah, this is all the example we have.
All right, so implementation challenges for this one, I'll toss it over to Andre.
Thank you, Ash. Oh, okay.
Do you want me to keep sharing?
Yes,
Sorry.
no, keep the slide on. I'll tell you when.
Sure.
Yeah. When
Cool.
okay. So in this case, we are talking about what kind of challenges do we typically encounter when we need to put together one of these types of configurators. The first point there, we do have a number of challenges with player interaction. How do we know, for example, how do we tell the user in a clear, intuitive way what pieces they can select? When they select them, how do they know, how should they know that they're able to move them? In what directions can they move them? And what are the constraints? Like what are the spatial constraints as to where these pieces are able to go, how far, in what direction, etc. So then, you know, maybe it is better if I if I switch to my screen and I can flip back and forth with examples. Let me just open the link to that in here. Okay. All right, so to show you an example of what I mean, I'll switch here to, oops, that's the wrong one. Nope. Oh, I see what I'm doing. I need to get this into a different tab. There we go. All right, so we don't know in this case with the left side configurator, we don't know what is selectable, in which direction you can move it until you actually click on something. So the only way you can figure out how you can move these, or which ones are selectable for movement and for manipulation, is by just clicking randomly on things. This is what's been done on the majority of the configurators that we've worked on so far. There is no hover state, for example, so that can be a challenge because on mobile, it is difficult to generate a hover state of where your finger goes over the surface of the screen. And the next question is, in this case, you know, how do you know that something is selected? In this case, you will see that it's indicated through an outline. In the California closets example, you saw that that was indicated with a highlight of the items on the UI on the side. It can be done with a highlight of the whole 3D geometry of changing the materials, for example. But those are a few different challenges of how can you identify easily and differentiate easily between the selected items and the non-selected items. And then in terms of where things are movable, you see right now, this doesn't have any constraints. Maybe it should have been constrained to the floor. The choice in there for the client, I guess they prefer that it can go anywhere. And then on top of that, what are the constraints with things snapping to each other, connecting to each other? There are constraints in here that tell you that some of these pieces only fit with certain other pieces. For example, you see this one doesn't snap together to the other one. And you have to go through a journey of discovery to find out all of these constraints. There are some UI elements that can be added as helpers, but it's one of those challenges that need to be figured out. Okay, switching back to the presentation here. So next one, repeating patterns and realistic visuals. And this goes together with the performance budget, actually. They go hand in hand. In this example, what we're looking at is a number of elements that are being repeated over and over. you can see how the whole unit here is actually being repeated. So we have one single asset with the pillow that gets placed over and over again wherever you want to add more of it. And this can sometimes create, break the realistic visuals, because you're repeating the same asset and you're going to see the features of that asset being repeated. In this case, you see the creases on the pillow being the same across all of them. It is possible to have more randomization so that even though you're placing the same piece over and over, you can introduce additional models with different features that look similar together, but different enough to break up this repeating pattern issue. However, the downside to that is that you're going to require more geometry being downloaded, more textures possibly being downloaded, and that increases the load time for performance. Another issue with the textures is, in this case, you do not necessarily notice any repeating patterns with the textures, but as soon as you switch to a texture that has a more visible pattern to it, I'm going to switch to something like a fur texture, immediately that starts to stand out. And you can see these identifiable features on that fabric, which is supposed to be a fur, which is also supposed to have a more random distribution of the features on the fabric. But when you're reusing that same asset over and over again, this becomes a lot more visible, and it breaks that sense of realism. With some patterns that have an inherently repeating pattern to them, such as some of these fabrics, it may not be quite as much of an issue, although in your subconscious, it still starts to nag at you, because you do see those pillows being exactly the same piece of geometry. They repeat the pattern in exactly the same spots. So even though the pattern is repeatable and it's more accepting to our brain, the fact that we still notice the pattern repeating in the exact same spots creates that sense of CG, let's say. And we also have the likely scenario of lots of exceptions. So we have the possibility where this piece, as I illustrated before, only fits with certain pieces a certain way. It may have certain amounts of padding that's specific to this piece, but not other pieces. When you drag and you move it close to others, maybe it's supposed to snap from a certain distance that's different from the other pieces. All of these exceptions do create a challenge, and it can cause the logic to balloon very easily the more of these exceptions you have. And how to treat them at scale is part of the challenge. All right, over to you, Ash.
Perfect, thank you.
Are we saving questions for the end, by the way, or can we?
No, jump in now, John.
Yeah, I don't mind if you guys jump in and cut us off.
Okay. So sorry, video on for the question. So regarding the challenges that you outlined, Andre, specifically with the pattern repeating, is that something that we are like? Is that something that we plan to address? Can it be addressed? Or is it that's just kind of the reality of?
No. As I mentioned, it can be addressed, but it comes at a cost, most likely. And the cost is typically of additional textures and additional geometry, which increases the load time. So the more realistic you want it, the longer it's going to end up having to take to load.
Okay, that makes sense. Thank you.
Anyone else? Good question.
Oh, sorry, could I just
Jump in.
explain that? So the image I put here actually is an example of the product rule exception. So you can tell from that the left column, the mesh door cabinet on the top and the drawer cabinet on the bottom, they can fit, like they can align together without any gap. So this is actually an exception, because for all the other pieces, there always be a minimal gap between them. And this gap is due to the distance between the available slot on the uprights. So this is the other type of quite common challenge we have in all the spatial configurators. There are always like exception for a certain type of the product that you need to be taken care of.
All right. Anybody else? All right. So that was a quick summary of the different types of spatial configurations, the ways they're implemented, and also some of the challenges with implementation. Now we'll transition to what the platform can do, and then a bit forward-looking what we have planned. So when we take an experience, and you can combine the 3 different categories, their patterns emerge. So the first thing is, in a spatial or modular configurator, you select from a collection or a group of components or products. So like with the Lovesac sectional configurator, you pick different pieces of the sectional. With PRX, you pick the base and you add accessories. So you build up your own product. So in the platform, the first problem to solve is, how do we give you that attribute? How do we provide an attribute where you can select from a group or a collection of different components and products, and you can select multiple instances of the same thing? So with Lovesac, I could have added no sides. I could have added 4 sides around the thing. I could have created a chaise, 2 chaises. With PRX, same thing. You can add multiple accessories, and the shelving's another great example. 1 shelf, 5 shelves. So the first thing is, how do we even define that attribute and store it? The second challenge is now jumping over into the player. How do we give you the ability to make certain parts of your product or scene selectable? And then once it's selectable, to interact so that you can move it around. And then once you add movement, how do you add constraints? And I think the PRX one was a great example where the rack had a constraint where it could move horizontally along the wall with distinct points, but then the barbell attachment to the wall could move vertically freeform, but also at horizontal constraints. So now you're starting to add some physical rules. So I'll jump over to the platform, show you a sample asset, and then show you how we put it together in the editor. So in this demo, this is like a living room collection builder. What I'm going to do is select from my product catalog and basically build a living room and show you all these features coming together. So the first thing was the attribute or collection or group attribute. There's a bunch of different names. Internally, we call it array attribute. You can think of it as a collection or a group attribute. And once I click this, I've already defined what the customer can select from our catalog. This is arbitrary. This is what I select. These are the product options here. So I'll start with a sofa. And as you see, when I select sofa, it places it in a designated area. Then I'm going to add a sofa. Then I'm going to add ottoman. And then I'll add another sofa. So as you can see here, I was able to pick from my product catalog, add the different objects here into my scene. What I can do now is actually swap the replacement. So if I wanted to drag this one on the right-hand side, you'll see that swap. So this is similar to the Brasseler example where in the physical space, I'd swap the different drill bits. I can also do it with the attributes here. So it swaps the replacement. Now we also have rules in this system. For example, in the living room, you don't typically want to put a sofa right in the middle here. It's usually reserved for a coffee table or ottoman. So regardless of what I select here, it'll always default to ottoman. If I try to swap something in the 3rd spot, it'll swap this into an ottoman. So we can actually put some of these rules in, and this has to do with the exceptions and constraints we spoke about. This is more for the product selection aspect. So this is the first component, just the way of defining the attribute, the different options for the customer, and some methods to be able to rearrange your selection. So if I want to move shelves around or drawers around, or in this case, different pieces of the furniture. So that's step 1. The next step is actually selection and drag. So why don't we do that? I can select the ottoman here, and you'll see the highlighting that was shown off earlier in the Lovesac demo, and I can freely move this around. Now, the movement here is constrained just to the floor or horizontal plane. Similarly, I can move this piece around and rearrange the room. Now, as Andre mentioned earlier, one of the challenges here is how do we make it clear to the user what you can do? So here I can click, but until I actually move it around, I don't know what I can do. And I don't see a way to rotate. So that's one of the first challenges. For the different methods or interactions, like with Brasseler and the drill bits, you don't need to rotate. You just move them. With furniture, you would typically need to rotate them. And Lovesac had their own rotate tool built in. So in the platform right now, you can select and drag, as you can see here. Now, the next thing has to do with constraints. So I've constrained these pieces to move on the floor, and also they can't go beyond the floor. So if I try to move them, you can see there, I can't move it beyond the floor. I should fix that, but it's going halfway into the wall, but I can't go further than there. So I've also added a constraint here that I can't go beyond my floor. The other part of this is combined. So like PRX, so these you can see they have one set of rules. You can move around in horizontal or horizontal plane with constraints. The dresser, like PRX, if I zoom in here to the dresser, this can also be moved around. But this is constrained to the wall. And you can see I can't go beyond the wall. And in this example, I have some props. So I have a staircase, and you'll see it can't actually go into the staircase. So I stop the user from going there. So I have multiple objects in my scene here in this collection. I can move them around. They each have their own rules. And the other part of this is each component has its own configuration as well. So now we're going to go one layer deeper. So I've arranged my objects, I've selected my products, but these are actually products from my catalog. These have their own configuration. So if I go over to this sofa, I can pick saddle leather. If I go to my ottoman, and you'll see it change down here on the screen, I'm going to pick bright red, just so it stands out here on the demo. Let's move this out of the way, zoom a little, and let's pick this last one, configure. In this one, let's do blue, just so it stands out again. So these are independently configurable too. You can reuse your existing product catalog to create these groupings or collections. The other thing I can do is if I go into, zoom into my dresser here, this is also configurable. And this configuration has another modular configuration built into it. So I can start to add accessories on my dresser. So I'm going to pick flowers. I'm going to add a set of books. So you'll see the books come in here. And these also have some physical rules. So here I can move them along the dresser, and I can't obviously move them off. And I can move them around, put my books here. And maybe I want 2 flower plots. Actually, let's do another set of books here, books on this side. And so now you reuse the existing product catalog you have. You can make each product configurable. You can add modular configuration to each product. Another example is if we added pillows to the sofa, I could add pillows and move them around the pillow and constrain them to the sofa. So a lot going on here. And as you can see, there's props as well. There's things here I can't select, I can't drag them, like the stairs. There's a whole combination of the concepts. John?
Are there limitations on how complex the configuration for the individual pieces? Or like how many different config options you can have for the apartment couch, as an example?
The first thing that springs to mind is that performance budget. I think that's probably the first thing you'll run into, because what we're doing is we're reusing existing products in our catalog that already have configuration. I can just open this dresser and configure it on its own the exact same way. I've just also embedded it in this experience. But maybe the rest of the team can jump in with other considerations.
Yeah, I don't know what the limit to the actual array attribute is. I don't know if we have one, Ash. Do you know?
That's a good question. I didn't go over it. You actually define how many things people can select, so that's how you can manage for it. So here I've said you can only pick up to 3 accessories. In the living room back here, you can only pick up to 4 furniture pieces. But in terms of like, can you define an array with 1,000 options? I'd have to look into it. I'm sure we have an upper limit there.
Yeah, and like Ash is saying, before you would hit that technical limitation of, let's say, 1,000 options, the performance hit, not even the amount of geometry necessarily, but having 1,000 objects in the scene is a performance hit on its own. Just that large number of objects is an issue.
Dozens. Once you get to dozens, like anywhere up to like past 100, you're going to start running into probably performance issues, unless they're incredibly simple, like a peg or something. So, but generally, people don't have time to configure 1,000 items.
Yeah.
It could be automatically generated though, and like not necessarily people individually configuring that many of them, but there might be some products like a chandelier with 300 candles in it or something like that.
That there should be that's an interesting optimization problem that would be fun to handle.
Yeah.
I'm just thinking about some like the high-end furniture companies that I'm talking, like luxury furniture, where they have crazy offerings for a sofa as an example. Could there potentially be a scenario where it's like, okay, I start with a sofa, I go somewhere else, I configure it, and then that new configured one, it gets brought into this room scene?
Oh, that is interesting. So instead of starting from scratch here, I've already configured the sofa. Now I want to create like a living room using that existing configuration I have.
Correct.
It's possible
How
by
do-
scripting right now,
Yeah.
because the configurations are the same. There's just not an automated tool in our API to do that without
Yeah.
some custom code.
Okay.
But the
This is-
trick would be a config link, like those saved configs
Yeah.
that you insert into one of these.
So I think you can do it, but not with the tooling we have. You'd have to add a bit of your own custom code on top.
Yeah. No, that's cool. Yeah. I mean, I think like just figuring out kind of like an elegant workflow. I mean, the building blocks are here, the foundation is here. So this is really exciting.
Mhm. Any other questions before I show how this is actually built? Some of the tools we use. All right, so let's start with the attributes and rules. So let me edit this and, oh wait, there's one more thing. This checkbox here. This is also compatible with our dimensions tool. So as I build my layout here, our dimensions automatically update. So it's one thing to build it, it's another thing to see, like my room is, let's say 15 by 50. I love this arrangement, but it's already 16 feet. This is already too big. So then you can play with it, get your real-time dimensions. And I have some room, so instead of requirement sofa, let me use my larger sofa here. Perfect, that still fits. And the last thing you can do is actually use AR and view it in your space. Now this will have to take some curation, but in this case, what would happen is all of my products here would be put in my space exactly with this layout. So you have to make sure you have room big enough for this to place it so it actually visually makes sense and is usable. All right, so let's look at some of the pieces that go into this. The first thing is the attribute. So you'll see down here, this is for my seating or furniture selection. I've set maximum number of things a user can select is 4. And here's the different options they can select from. And these are products already in my catalog, as you saw. So if these have configuration, their own rules, that's also carried into this scene. So that's the first piece there, using this array attribute. The next piece I want to show is the rule for the ottoman, where I say anything placed in that position has to be an ottoman. It's pretty straightforward. It says for seating at index 2, which in non-programming terms is actually the third item, the value has to be ottoman. No matter what you do, if someone selects something else, set it to ottoman. If someone drags something in that third position on the right-hand side where I showed it, it has to be ottoman. And so you can set up conditions too. You can say if an ottoman selected at this spot, the next item has to be a sofa, so that you don't have what I created there, which was a little bit silly, which had an ottoman and then a floating ottoman. So you can start to add conditions that says if I see something in this spot, the things after it can't be this or must be part of this group. Brasler is another great example for that. When certain drill bits were selected and they were large, you can put rules that say if something large is put in its spot, here are the things that could fit physically, and you can use our rule system to do that. So that's the attribute side. Let's jump over to the editor and go over some of the 3D components here. So this is my model asset that controls all the pieces you saw that I interacted with. So I'll just break it down. So you'll see here the wall. Now the wall is here just visually. I don't actually have to have a wall here, but it communicates to the user like there are some limits here, and the limits match the wall. Same thing with the floor. The floor is there just as a stylistic choice. So you can see that, where's floor constraint? Let me hide that. So that you know this is sitting on something and there's an edge to it. And then these pieces are placeholders. So it says model 1, 2, 3, 4. I've set them to furniture pieces. So as I'm building this, I kind of have a sense of what's in the space here. Makes it easier for me to build the experience. But these are placeholders. Obviously, the end user gets to pick what goes in these spots. But these placeholders are important. These are the points where I was selecting options and it dropped it on a specific location. This is how I set it when I'm setting up my asset. So I put these placeholders here, and you'll see these are the designated spots. Once they're placed here, then I give the user the ability to actually move them around. But I give them a nice starting point. So if they end here, they have something visually appealing. Same thing with my dresser. I've put it here. This is just a placeholder. If any object gets dropped in that attribute slot, it gets placed in the middle of the wall there. So if I were to move this around, if I put this here in my asset, when a customer goes and builds, as soon as they drop something in, or perhaps the sofa, it'll actually be placed in this spot. So I've basically arranged where I want everything to start. Let me hide dimensions. We can get back to that. I've basically set up my placeholders. The next step is to add the ability to select and drag and provide some constraints of how people can interact. We have a concept called a layout container. This is how you add it here. And I have two. So you'll see I have a layout container for the floor, and you'll see the things it's constraining with the highlights here. And then I have a layout container for the wall, which is set to constrain this. And if we look at the properties, we'll see how this is all put together. Let me hide this. So the layout container basically asks, what should I use for the constraints? I have a plane here called floor constraints. Let me just show you that. Hide this. That is the limit. I can drag around that constraint. I can't go beyond the edges. And so with the layout container, you basically set what is setting the constraints. In this case, it's what you see here, highlighted in yellow. And then I can set some stylistic choices, like the outline color and thickness. Andre mentioned this with Lovesac is like an interaction queue. This is a starting point. He mentioned some challenges we have already with things like hovering and how do you know what you can do with it and the limits and so on. And that's essentially it for the layout container. You add a container, you set what is setting the constraints. So it's this floor here. And then you put anything that needs to be constrained by it as children here. And then I've added another one called wall layout container, exact same concept. What is setting the constraint? So let me hide my wall and show the constraint. And you'll see here, it's more of a line because I don't want it to go up vertically. I don't want any movement vertically, so it's a line horizontally. And you'll see it goes here because the stairs start beyond there, and then it doesn't go past the wall. And then the last piece here is the dimensions, which I'll show you how quickly, how easily it works. We have dimensions here. You can add box dimensions, which automatically calculates the dimensions of whatever you select. And I've basically selected all my 4 placeholders. So as you add, this will automatically, and you can see it here in real time, calculate the dimensions, and I've set units and some stylistic choices. And that is the setup. You basically put your placeholders of where items should be dropped. You set your layout containers that dictates the constraints physically. And then I've added dimensions here, which obviously not a requirement, but really handy when you're building a living room. Any questions before we move on to what is coming next? Anything else the team wants to add in that I may have skipped or forgotten? Cool. So demo we did. So what is coming next? There's still 4 really important components. The first one is, and these are in development. The first one is once I've made these choices. So when I built this room, and this is somewhat similar to the question you had asked, John. So let's just add some random things just for illustration so I can talk about it specifically. Zoom, 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 move this around and move this chair over here. Whoop, chair, move it over here. Cool. So I've made this configuration. Right now, out of the box, we store anything you select on the right. So whatever you've selected, whatever choices you've made here, even including the dresser, I add these things. These choices are all stored. So by stored, I mean, if you add it to cart, Threekit stores these automatically, all your choices here. What we're adding now is storing the physical properties that you manipulated so that we can restore like a complete experience, not just your choices on the right-hand side of like what products you picked and their options, but also where are they physically in space. In this living room example, it may not be as important, but in the PRX example, it's definitely important. In the CTEC with the desk and the shelves and where they were placed, that's really important. It could be important to manufacturers to know if it's built to spec. It's also important for the user. If they order something and then they get it and it's not compatible, they can restore it and say, well, this is what I ordered. The rule said I can do it. And for a manufacturer, it's really important, or sorry, the brand as well, to make sure that whatever is ordered is to spec and follows those rules. So we're adding the ability to basically store everything you see here as well, along with the product option choices. So you have this kind of complete picture of your configuration.
Is that through the API, Ash, or is it when you save an order?
Well, when you save an order, it does use that API. So yes, it's through the API. It's also like social sharing. So here, when I click share, this is save the configuration. Same exact API endpoint.
Okay, so even that share creates a
Mhm.
configuration which pulls up all of the things you've just described in here. Exactly.
Right.
Okay.
Yeah. And we're also going to add even the camera angle you've added, so that if you want to take a snapshot of this when you add it to cart or an email confirmation, you get to see exactly what the end user saw.
That's being worked on now.
Yes, that is currently in development. The next one is collision, which is also in development.
Just one note about that. You can already do that, John, if you have an attribute for camera angle. And so if you have an attribute, any attributes and their values get stored with the configuration automatically. It's just, I guess Ash is referring to the default camera. If the user just rotates it somewhere else, that's not being stored, and that's what they're working on.
Yeah, that's a great point, Andre. So everything, like you've already seen Lovestack and Browser and all these other projects, they were built without these features. So you can get to the same outcome. The goal is to productize all the implementation work so that you don't have to. So yeah, you can replicate everything I've talked about that we're developing, but we're basically adding it into the platform. So it's like no cost implementation.
Yeah, understood.
Yeah. The next one is collision. So collision basically addresses what happens when two things collide or interact with each other. So you can see here, and we saw it in Lovestack. Basically, it allows it in Lovestack. There was a bit more logic where it would highlight and make it red to tell the user you can't overlap these two things. What collision is going to allow you to do is in the same editor interface here that I showed earlier, you get to dictate what happens. And a bunch of different things can happen. The first and most obvious is I can't drag any further. The next one is, and I think Chen spoke to these, where there's actually some spacing where I can't get closer to this. It's not exactly like when they're intersecting like this, but maybe there's some padding or spacing that has to be around it. PRX was another great example. You couldn't actually go to the very corner of the wall. You actually had to leave one stud of space. And same thing with California closets and shelves. There's spacing and the exceptions come in. So when these two are interacting, here's what you should do. But with these two, maybe there's a different behavior. And collision is basically, we're starting to wrap up like the physical rules. What happens in the real world when two things get close to each other or collide? There's some things that happen, and we need to replicate that so that this feels familiar and logical to someone interacting with it. And the second part of collision is just the business side rules. Some parts cannot be touching. This is something the business has decided, and they need to be able to enforce those rules. That's collision. The third one is automation. So automation, speaking specifically to the task where I had created these 4 placeholders where my objects can go. This isn't a big problem when I have 4 or 10. But I think the question came up, what's the limit? What if you allow a user to pick up to 100 things? Closets, very much like once you add the columns, you could be up into the 50s. So what you wouldn't want to have to create 50 placeholders and place them. And so what automation does is based on the number you've set, so down here I've set 4, as the user starts to add selections in the 3D space, we can add placeholders automatically. So it saves the task for an artist. And with that comes some rules. So where is the first placeholder? So perhaps it's in the middle. And you will always keep these centered. So once I add a second one, it will move it so both of them are centered, 3 are centered. Or maybe you start from left to right or from back to front. So we give you these rules, and a lot of design tools have these automatic distribution, distribute vertically, horizontally. Like in 2D space, we have a lot of these tools, and it's the same kind of outcome we're looking to implement, so that you don't have to predefine every single placeholder. And the last part is to address some of the examples that Chen had shown, and they go together with automation, where it's not freeform, there's discrete spots. So a discrete, or like, you'll see multiple names for it, and I covered them all. So discrete, there's discrete 8 points you can place these drill bits, or it's a grid, or there's attachment points. And so attachment points can cover like left stack. When they get close to each other, they attach. So combined with collision, combined with attachment points, putting it all together, these 4 features, it's to productize the examples you saw earlier so that teams don't have to implement it on their own with any sort of custom code. And just make these kind of experiences accessible to more people. Any questions on these?
I don't have any
well,
questions
thank
on those topics.
Go ahead.
I just had one question about something else. So yeah, I'm seeing this sort of functionality come up with more and more with the focus on furniture, right? Really cool to see, just even in that demo, like having the different like accessories and things like that to make the space more lifelike. Any thought or consideration, or I mean, what's even the lift like to start doing something where a customer can start to put in dimensions on a room to essentially build that space or that scene that's going to be more like their own living room or something?
So the lift to basically create this kind of experience with dimensions.
Yeah, like instead of it being a square, it's a rectangle that has a bay window on the end.
So is the question to customize the living room and everyone builds in that one living room, or give you, the customer, the end user, the ability to build the dimensions of your room?
Give me, the end user, visiting a website, say, okay, I have these walls and this here is a circular cutout and blah, blah, blah.
So I to design the floor space.
Yeah, I define the dimensions of my own living room.
I understand. Yeah, so that is a bigger lift. This is why I was careful not to call this room builder or floor planner. This is modular or spatial configuration. We're not at that point yet where it's productized, where you can actually dictate the floor space first and the design of it, and then place things into it. So there's much more. Yeah, this is more, we give you a curated space and maybe you can pick from templates. Yeah. And there's some ability now where I can have sliders and drag, like my room is 12 by 18, or maybe it's 14 by 15. And you can drag those and the constraints will respect it. But in terms of like the curved walls, you can probably get close with the platform with tooling, but it feels like there's a lot more implementation there. But yeah, Andre and Chen, you can help.
It can be done with a modular setup the same way, where you're essentially defining the floor plan with individual pieces that have the different shapes, kind of like putting a puzzle together. You could do it that way with this layout container. The challenge is that may not necessarily be the intuitive way for users to think of putting together a floor plan.
Mm-hmm.
So it's a combination that I think is primarily a UX issue, and how that gets translated to from them wanting to, let's say, more or less design the outline of a floor plan using vector graphics. That can be converted to a shape. We do have that feature on the platform to convert a curve to a shape. They could plot points, for example, and we can generate the curve based on those plotted points. But it's like I said, it's primarily a UX challenge.
That makes sense.
Yeah,
I think the idea of templated dimensions or the sliders, or even a combination of the two, should probably check 95% of the box, and make it a more intuitive experience for the majority of users. So
we have a lot of use cases where people design things in a 2D view and then they switch to a 3D view, closets and that. So productizing a feature set around that may be worthwhile at some point. There is a pretty well-defined way of doing that.
Mm-hmm.
There's definitely a lot of details that may go into it, though, beyond the obvious of draw something in 2D and go to 3D. And Ben, you've presented on this before with a CAD design UI, where dimensions are very important, right? You have to be able to specify this section is this in terms of dimensions, this section is this much. etc. And all of these little details, they do add up to a lot of features. So that's what I think where the big lift goes into, to be able to accommodate all of these requests for the UI.
That makes sense. Thank you.
Any other questions? All right, well, thank you. I think we're all
Thank you,
set.
everyone. Yeah, thank you, everyone, for attending. Thank you, Ash, Andre, and Chen, for giving us an excellent presentation of where our platform is now and where it's going. For anybody watching, if you have not been there yet, community.threekit.com is where this will be posted. And we have all sorts of wonderful resources there about our platform and how it works.
Thanks again.
Excellent. Thank you very much. This was
Thank
great.
you.
See you.